Hey everyone, this is Josh Goosen. This is my particular project for educational technology at Georgia Tech, and I am focused on PYYing projection mapping, really looking at projection mapping, what it is, both in terms of educational technology, in terms of theater, education technology, and also just different teaching people how to use the actual technology in of itself. So this is really just to summarize my particular project and the PYYing projection mapping solution that we built. It's more of a prototype or a concept piece, I think, to demonstrate how this technology can be built relatively cheaply for technologists and then used potentially by small-scale theaters. I do want to point to that fact that I have some background in circus arts and visual arts. This is really a perfect project then for me because I got to kind of conjoin my computer science work with projection mapping and my visual arts background. And really, this is an old technology. I did some background research. This is something that was used way back 2,000 years ago. Conceptually, it's the same thing as what the Chinese were using in PYYing theater, which is where we get our name from. Conceptually, it's the same thing as Plato's allegory of the cave, where it's the essential allegory of enlightenment, knowledge, and education. So, I mean, this has many pathways back to education technology, I think, and essentially what we're involved with is communication, which is fundamental, of course, to education and everything. We are now today mapping pixels instead of donkey skin, instead of casting shadows. We're projecting pixels and in the absence of pixels or light onto objects. This is something that is done at a very large scale at Disney, and many of you may have seen that, but it's becoming more small scale, more accessible, and we're kind of continuing that trend now using free software, using Python, OpenCV, NumPy, SQLite, and open source solutions to more or less liberate the technology, make it more visible. Ironically, we're projecting projection mapping out and into the world so that other people can use it. We leveraged a lot, of course. We are just really progressing this natural, this monster, I think that's moving. There's a lot of math that goes into this. There's a lot in computer vision, particularly when you're getting into real-time projection mapping. You need to be able to detect edges in motion. So we read up on that. We read up on the latest technologies, the software that's out there that you can either pick off the shelf or use as open source. By the way, none of the open source is actually in Python. None of it actually is up to date. And we're the only product then that's in Python that is free and open source and available. We used OpenCV solutions. We read up quite a bit on that. This is our particular implementation detail. I think we reused OpenCV, Python, Tinker, which is used for the GUI, and Qt5, which was an alternate GUI, which we ended up not taking. That's a route. We repurposed hardware. We had a cheap projector, a cheap laptop, a cheap webcam, and we made it all work together relatively quickly to build an actual solution. And then, of course, we used particular code from GitHub and YouTube. Not getting too much into the details here, but this is a picture of our development environment, the hardware, the laptop, the projector, etc. These are some pictures of our demos, which we used because we wanted to actually understand OpenCV before we went and built our design, and I think that was very effective for effective for my solution. The paper goes quite a bit into the design and the components, and so I'll share a little bit here, but effectively you have to imagine there's an operator that develops the show using controller and canvas tool. This is part of that controller. Basically very simple, a couple buttons. You want to draw the surface, you want to throw the surface. Drawing the surface throws the data into database table, which then represents the surfaces in relation to a particular projection scene. So PROG means a projection scene. And this is the sequence. So you have the surface table, which will list out all the points and effects that goes into surfaces. Those map to projection scenes. So you imagine you have an act. The act is divided up into multiple scenes on a stage. You can sort all of that out using these two tables relatively quickly, get a data model of all of that information. That's what we did. We use a GUI control class. We use a canvas window or class and a projector class to do most of this work, whether you're controlling and opening the canvas window or opening the projector class, or whether you're interacting with the database and building and drawing the surfaces, which is part of that initial phase. Is almost like a software lifecycle, but it's a scene lifecycle. You have to actually build your surfaces and put the videos into them. And then your projector class, which actually does all the demonstration and the actual work of cutting and slicing polygons, putting videos on top of them, and sending them off onto physical space. Again, the majority of the work is done by the projector class. There's a lot going on here. Cut, slice the frames, turn them into matrices, perform bitwise and and OR functions to conjoin the frames with the videos and with the other frames for other videos and with the other polygons. This has to be done very quickly and very precisely, or it just doesn't look right. We also added an interactive function which merges together with the polygons and surfaces. And that's something that also no one is doing at the moment in open source, as far as I know. A lot of challenges. I'll cover these briefly, but we had challenges getting everything to work together. That's typical. I think every software project I've ever done, that's always a good portion of the work, is just getting things to talk to each other, getting the code from GitHub or YouTube to actually work. You had to, of course, you have your own particular version of Python. The code you get from GitHub or YouTube might not be that version. So even just understanding how the functions work can take time, because you have to download the code, find out what doesn't work, troubleshoot the part that doesn't work, hope that that's the issue, and then continue down the path until it actually works, and then you have code that you can build into your project. I lacked familiarity with the GUI systems. I lacked familiarity with all of this, so that's also a challenge I had. OpenCV lacked controls to manage Windows. It took a number of days just to figure out how to overcome that. I had to get the code to talk to the Windows operating system and adjust and manage the window, the way the window appeared, so that it didn't effectively, it would show up and not appear in your projected stage. You would have just the pure elements that you want to focus on the stage instead. Lack of familiarity with building all the matrices and the computer vision and cutting up the frames, of course, was another challenge I had. Parts of the OpenCV did not work with the interface. Not really sure why. I did find a workaround with background subtraction so that I could cut actors out and throw them onto a stage as a ghost or any other effect. And I think also key here, we were not able to paint directly onto actors. And that's because of a problem with, we had to revisit how the frames from the live camera match up with the actual projector. Our workaround was to take the camera, point in a different direction, capture the actor dancing, performing aerial, could be a different angle of the same scene, and then to project that onto the background. So it doesn't quite paint onto the actor, but you can project the actor elsewhere in space as if he's a ghost. So that's still valuable, I think, contribution that we can have an interactive, again, projection mapping. You see some of that here. You see some of the stage work here. We tested this with 10 different stage configurations, live actors, and actual geometric shapes. And we learned, of course, lessons. Basically, our GUI is not up to par. People can't learn how to use it very quickly. It took me about 20 minutes to show a stagehand how to use it. To fix that, I want to make a PowerPoint looking version of this. and I think that would make it more accessible to teachers or theater professionals, etc. Anyways, I definitely enjoyed this project. Wanted to thank the professor and the teacher assistants, and I think this was a great class, and I'm looking forward to continuing to use this technology as moving forward. Thank you.